Hello everyone, welcome back to my channel. Our topic for today is identifying the appropriate rejection region involving population proportion. Let's do it. There are two ways to test the hypothesis involving population proportion. First is with a p-value approach, and the second is with a critical value approach. So we will be discussing only the critical value since this one is easier. The critical value enables us to reject or not the null hypothesis. Okay. Also, it is calculated through alpha levels and symbolized by Z or Z tab. So the critical value or Z tab, meaning to say we will be using here the Z table. So the Z tab separates the rejection region from the acceptance region. We know that already. Derived from the level of significance and expressed as the standard Z value symbolized as Z tab. And of course, the level of significance, alpha, refers to the degree of significance in which we reject or do not reject the null hypothesis. When we say we do not reject, meaning we accept the null hypothesis. The basis for the critical or the rejection region dictated by the alternative hypothesis. Take note of that. The basis for the critical or the rejection region is dictated by the alternative hypothesis. Now, this one is our Z scores. So, the level of significance, we have 0.01, 0.025, 0.05, and 0.10. And we have the left tail or one-tailed, and then the right-tailed, and we have the two-tailed. So we will be using only this table. Let's now have these examples. 1. A sample of 100 students is randomly selected from the Thai Senior High School, and 18 of them said that they are left-handed. Test the hypothesis that less than 20% of the students are left-handed by using alpha 0.05 as the level of significance. What to do? A. Identify the level of significance. B. Formulate the alternative hypothesis H of A. C. Determine the critical value or the Z tab. And D. Illustrate the rejection region in the normal curve. So let us follow these guidelines. Letter A, identify the level of significance that is 0.05. Letter B, formulate the alternative hypothesis. So this is H of A. The proportion is less than 0.20. So it says here, test the hypothesis that less than 20% of the students are left-handed. In words, we can say that the proportion of students who are left-handed is less than 20%. Okay, that's letter B. Now, let us go to letter C. Determine the critical value or Z tab. So, our Z tab will depend, of course, on this one. This one is left-tailed. Left-tailed. Okay. And our level of significance is 0.05. So, our Z tab, therefore, is 0.05, left-tailed. That is negative 1.645. And for letter D, illustrate the rejection region in the normal curve. So this one is 1.645. This is negative 1.645. This one is our normal curve. And this is our Z tab or the critical value. And it says here less than, so therefore this one is the rejection region. Example number 2. A sample poll of 300 voters from Taytay Rizal showed that 56% were in favor of a given candidate. Test the hypothesis using 0.10 level of significance. What to do? Identify the level of significance. B. Formulate the alternative hypothesis H of A. C. Determine the critical value or the z-tab. And D. Illustrate the rejection region in the normal curve. So letter A, identify the level of significance, that is 0.10. Next, letter B, formulate the null, that is H of A. So it says here, show that 56% were in favor. So that is the population proportion is not equal to 0.56 or 56%. In words, we can say that the proportion of voters in Taytay Rizal who were in favor of a given candidate is not 56%. Letter C, determine the critical value. So this one is not equal to, therefore we use two-tailed here. Two-tailed. And our z-tab is equivalent to two-tailed 0.10, that is positive negative 1.645. And letter D, illustrating the rejection region. So, we have here 1.645, negative 1.645. This one is the z-tab or the critical value. The rejection region will be this one. And this one. That's it.